can you guys all see enough to write, and you can see this? Okay, so this is what connective tissue is. It's extracellular matrix and cells. And in that extracellular matrix, we're gonna find collagen, we find elastic fibers, and we find reticular fibers. And then how these things are combined tell you what kind of connective tissue that it is. And so I sort of put this little game together, and I thought it was kind of a good illustration, and I'll put this in the lab for you guys if you want to play with it, but depending upon how you combine these three elements, you get all the different types of connective tissue that we have in our body. So I thought it was kind of a little childish, but I'm a child. Okay, and so, you know, anyway, these different, the way that you combine it, so you can see that we would have these different types of cells, reticular fibers, elastic, and collagen. And these would be representative of those types of cells. And the fibroblasts, this is a fibroblast. And fibroblast, whenever you hear the word blast, B-L-A-S-T, that is a kind of a precursor cell. So we have chondroblasts, osteoblasts, this is a fibroblast. Those will then become chondrocytes, osteocytes, fibrocytes. So blast is, there is a general term there that just means it's a kind of a, it's a precursor cell. It's a cell that is in development. So fibroblasts, we have a lot of fibroblasts in connective tissue. Reticular fibers are, let's see what I want to say about reticular fibers. Reticular fibers form, I don't even know how I want to describe it. So they're sort of they're just another one of these forms that you find inside connective tissue. Now the elastic fibers don't often stain when you see them in a microscope slide, so you might not always see the elastic fibers, but you could think of an elastic tissue, a connective tissue that has a lot of elastic fibers in it, would be something like the aorta that comes off the heart, because the blood that is rushing through that, it causes the aorta to expand and recoil. So when we talk about stretching and elasticity and anatomy, a lot of times what we're talking about is the recoil ability. It's not that it can stretch and stay stretched, it's that it stretches and recoils. And that recoiling is very important for the flow of blood from our heart, for instance. So that would be an example of a lot of connective tissue that has a lot of elastic fibers in it. So these would be some of the functions, of course, of connective tissues. We're talking about bones here. So, I mean, all of our, you know, we have so many of these tissues are so important. Anyway, okay. So anyway, this connective tissue, not only, you know, bones are support, binding body parts together, cartilage, tendons, ligaments, these are all connective tissues. Lipid storage, fat, adipose tissue. I mean, that's our fat tissue. We definitely need that. We've got connections between things. We have restriction of movement, as well as allowing movement in terms of cartilage as a connective tissue. And this allows for a lot of movement. The phagocytosis, this would be, you know, immune responses. That phagocytes are going to be traveling through the connective tissue. Transport of oxygen in the blood. And then mending of damaged tissue with collagen. So basically everything in our body has something to do with connective tissue. I mean, so it's a very important thing to kind of understand. And what we're kind of doing in this first couple of weeks of anatomy is really giving you, at least I hope I'm giving you some building blocks. So that, and this connective tissue is definitely a building block. And of course we talked about the embryonic and mesenchyme and mucous tissue. And a lot of our tissues come from our mesenchymal in origin. And then of course the mucous tissue, which we talked about, which is only found in the umbilical cord. So, you know, in terms of looking here, again, here is the nucleus of the mesenchymal cell and these reticular fibers. As you can see, it's this very delicate sort of connective tissue. So the immature, in all the connective tissues, those immature cells are always going to have that end word of blast, because that is an immature cell or a cell in development. Fibroblasts, like I mentioned before, osteoblasts, turn into cytes, which would be cells. Okay, so now when we go into this kind of mature types of connective tissue, then we have these 5 types. We have loose connective tissue, dense connective tissue, cartilage, bones, and liquids. And in the lab, well, we're going to encounter all of these actually. So, and then within each of these headings, you can see that we have different types within, like loose, areolar, adipose, reticular, dense, regular, irregular, and elastic. Cartilage, we'll talk more about different types of cartilage, very, very important. We have these 3 basic types, hyaline, fibrocartilage, and elastic cartilage. And then bones, of course, osteocytes. I want to make sure I give you you'll get a very good understanding of bone growth and development in this class. And the reason that we include it in anatomy, because unless you take osteology, and even then, I don't know, I don't think the physiology of bone development is covered in other classes, so we kind of try to cover it in anatomy. If you take an osteology class, it will be covered in there, but this is kind of your mini osteology class. And then, of course, liquids, blood, and lymph. So when we talk about loose, we're going to talk about this top part here, loose. We have these 3 types, areolar, adipose, reticular. And so the first thing we do when we open up the body is when we pull the skin back, you're going to see this fascia, which is this loose areolar tissue. And it is this kind of spider web-like material. And this fascia is superficial. We have deep fascia. We have, sometimes the fascia gets very, very dense. And you're going to become very, very familiar with areolar, loose tissue. And then adipose tissue again. Humans, you know, we have fat. We put fat everywhere. You will be shocked at the places in the body where we find fat. You know, even if a person is very thin, there's still a lot of fat. We have to have fat in our bodies. So we have fat sort of everywhere. And it's very good. We have blood vessels that transport through fat. Too much fat, of course, is not healthy for the body for a variety of reasons, one of which, fat has a lot of blood vessels. And not only are you going to be putting, if a person is morbidly obese, say, not only are they putting the extra weight and effort on their joints from having that much extra fat and weight, they're also increasing their blood supply and the demand on the heart, because now you've got a lot more blood vessels than you had before, and so you're having to pump out a lot more blood. And so it's kind of this spiraling down, which is why obesity can be so harmful. And then reticular, you know, these are the fibroblasts with branching types of fibers. We find them in the phagocytes of the liver, spleen, lymph nodes, bone marrow, this sort of thing. And I'm going to show you some pictures of these, and then we're going to, after we do this, then we'll talk about dense connective tissue. I kind of divided it up to make it a little easier to understand. If I understand it, hopefully you'll understand it. So when I was reading through my notes, I'm getting a little scratch in my head. So, okay, so loose areolar tissue, loose connective tissue. So it has collagen, elastic, and reticular fibers. These are the types of cells that you might find. White blood cells, plasma cells, adipocytes. We'd find this, the typical place would be the subcutaneous section. We have here, you can see the cells, you can see the elastic fibers, and collagen, and then some mast cells. So you can see this. This would be when you found, if you found this type of material in this connective tissue, then of course it's pretty obvious. When it's loose areolar tissue, it's pretty obvious. It's kind of, it looks like it sounds. it just looks exactly like what it sounds. It's loose, it's irregular, it's like spider webs. And when we look at adipose tissue, again, you know, it's from this, we have this adipose tissue, is vascular, a lot of, like I mentioned, with, let me see. Yeah, so, you know, adipose tissue, fat, we have fat, the lining around our heart, we have fat around our kidneys, that's protection around our kidneys. If we didn't have this fat layer around our kidneys, they're right here, they're very exposed, so that fat sort of helps to protect them. Fat can be a secondary sexual characteristic. I mean, women have just a natural kind of layering of fat over the whole body, which is, you know, makes women more curvaceous and also is helpful to, as that storage for pregnancy. So brown adipose tissue is pigmented from the blood vessels, and usually this is tissue, brown fat has usually been around for a lot longer, and the blood vessels kind of stain it. And it's more prominent in newborns as well. So that's just kind of when you look at fat, adipose tissue under a microscope, that's what it looks like. And of course, obviously, triglyceride storage. And then the reticular, and then reticular connective tissue, again, would be this loose connective tissue. We might find this in, this is showing you inside of a lymph node. And it would also, you might find it in some of the other organs. So it would have a very thin, it's like a, reticular fibers are a thin form of collagen. And, you know, it's removing, like, removes old worn out blood cells. That would be in the spleen. Oh, reticular, the word reticular means net. So the reticular fibers kind of form like a network. So now when we move into dense connective tissue, we're going to have these three types: regular, irregular, and elastic. Regular, just like it sounds, that would be, you know, a lot of these would have a lot of extensive, you know, collagen and elastic fibers. It's going to be looking very, very regular in configuration, sort of like this. So that would be something you might find in the tendons and ligaments. And when we talk about muscles, we'll talk about where this tissue comes from, because it's kind of interesting how the tendons are formed. But, and then irregular are these fascia sheets that are under the skin, and they're very, very good for stretching. And then, of course, the elastic, like I mentioned, in the aorta to allow this recoil, and especially our lungs as well. You know, I can expand my lungs and I can recoil them back, so they obviously have a lot of these elastic fibers inside of them. Here's some pictures of, this would be a picture of the tendon. It's a shiny, tendons look kind of like strapping tape. You know, they have a very regular lines. And the formation of the tendon is actually the fascia that is surrounding each of the muscle fibers, and then it just kind of extends. It's kind of interesting. But, and this is not very vascular, so you're not going to get very many not very much blood supply in a tendon or a ligament, which is why they don't heal very rapidly. If you tear a ligament or a tendon, they don't heal fast at all, because there's not a lot of blood supply. And the fibroblasts are found kind of in between the rows of fibers, so you get this very regular laying down of tissue. And then dense, irregular tissue we would find in the dermis of the skin. And again, it's dense, so we would find all of these things packed very densely, but in an irregular kind of configuration instead of being very regular. And it occurs in big sheets. And then elastic connective tissue, and again, like we would find in the aorta. And when you see the cross-section of a blood vessel, you can really see those elastic fibers. And they're very, very prominent in any, in the arteries. When you see a cross-section, you'll see all that elastic lamina that layer of elastic fibers. Okay, so that's kind of connective tissue in a general term of that type, of those types of connective tissue. Now we also have cartilage as another type of connective tissue. And cartilage, we find all different types of cartilage. We have basically have three types. We have a hyaline, we have elastic, and we have, let me see right here, what is the last one here? And fibrocartilage. So these are the three basic types of cartilage we have: hyaline, fibrocartilage, and elastic cartilage. So in a hyaline cartilage is the most predominant form of cartilage that we find in the body. And hyaline cartilage, let me go back here and show you. There's actually a YouTube, I found a great YouTube video, which maybe we'll look at it. So this is hyaline cartilage, this one. And you see how the cells, the chondrocytes, the chondroblasts and chondrocytes, kind of get walled in these little lacunae. These are called lacunae, these little circles. And what you're seeing is the nucleus of the cell inside this little lacunae. And this is very characteristic of cartilage, that you have these little chondrocytes inside the lacunae. Now, the difference between hyaline and elastic is just the elastic fibers. So you have more elastic fibers in this cartilage, and you can still see the lacunae. And this is stained very dark to see the elastic fibers. It's not easy to see elastic fibers in cartilage unless they're specifically stained. And then this is fibrocartilage. Now, a couple of interesting things, or something that is kind of interesting that I just learned about elastic cartilage, is that elastic cartilage is found in the parts of the body that begins with E, just like elastic. For instance, the epiglottis, the ear, the eustachian tube. So that's where you find elastic cartilage. I think it's kind of interesting like that. Just like the symphysis joints are all found in the midline of the body, there are just these weird little patterns that we find in the body, and I just love that. So elastic cartilage, they begin with an E. Just remember that. I think that's one of the questions about ear. What kind of cartilage is the ear? It's elastic cartilage. So, and I don't know if you guys want to watch this. Do you want to watch it on YouTube? You want to? If I can get, let me see. I should be hooked up to click it. Let's see. I should take us right there. Shotgun histology. These are great. You know, YouTube is wonderful. You know, it's a great study tool. I find the most amazing things on YouTube. Now let's see if we get my sound up.
Which means if you look at the edge of cartilage, you will have a harder time finding the lacunae, and the cells may look a little more spindly. These are the so-called chondroblasts, and they really don't look much like anything. You'd probably believe they were a fibroblast in any other type of setting. But as cartilage grows, these chondroblasts could become trapped within this bluish matrix or ground substance, and then appears to live in these little spaces called lacunae. And for the most part, you can think of mature cartilage as being a nucleus or a cell living within lacunae. Sometimes they are individual, and sometimes they look like they're in similar groups, which they call isogenous groups. And you will also notice that the bluishness or the density of the ground substance, which is chiefly hyaluronic acid, but a whole bunch of other things which we won't even mention, appears to be a little closer to the nuclei. And where you are widely between cells, it's not very dense and ground substance at all. Let's say a couple words now which will hopefully help you to understand cartilage forever. There's three kinds of cartilage. There's hyaline cartilage, which is the vast majority of all the cartilage in your body. And then there's elastic